Hello and welcome everyone. So in this section we are going to study about the gravity disc. Okay, so the gravity disc is very important for purifier operation, as it is the one which holds and maintains the interface or the boundary between the two layers, the heavy liquid and the light liquid, necessary to hold the interface between the light liquid and heavy liquid in the bowl in the definite range. Okay, so in case of purifier model, we have a separate set of the gravity disc that is being supplied by the maker, as we can see, because what will happen.
A message for every marine engineer out there. First time joining and scared of what will happen on board? Our Combat Achiever packages show real shipboard videos before you step on, so you join with confidence. Junior engineers still repeating those basic mistakes? Our basic troubleshooting package helps you avoid the same errors we all made on board ship. Fourth engineer, go in depth into purifiers and compressors. Izzat nahi kamani kya? Third engineer, learn auxiliary engine overhauling and boiler testing step by step. To all second engineers and chief engineers and ETOs, hydraulics, maneuvering, electrical circuit diagrams, PLC, PID, reefer and AC system. Guys, troubleshooting should be your forte. अगर जहाज पे इज्जत अपने juniors की चाहिए, तो troubleshooting आनी चाहिए. 24 packages, many more coming soon. 2-year subscription. That's M&D Flex, not a course, but a technical lifeline you need on ship. Check out our free trial videos. Link is in description box.
The question is ki what will happen if the gravity disc size is smaller. So if we employ this is the bowl, and if we use a smaller gravity disc, that means the oil which interface which was about to be made in this section is shifting inwards. Okay, so oil's interface is shifting inwards. So what is happening, the heavy liquid can go out into the light liquid, yani purified oil outlet chamber. Heavy liquid can go out into the light liquid, and if your gravity disc size is bigger, that means there is no pressure and the light liquid, so gravity disc interface boundary will form somewhere here outside, so the light liquid can go into the heavy liquid, can go into waste sludge, okay, into the heavy liquid. So your gravity disc need to be of appropriate diameter, so that the interface is formed between the top of the disc stack, tip of the disc stack to the tip of the top disc. Okay, somewhere here, tip of the disc stack to the tip of the top disc. Otherwise the interface will change its position if your gravity disc is not of correct diameter. So how is the gravity disc decided, that we will see in further section. Now as per the maker, there is only a set of gravity disc that is supplied for a set specification of a purifier. So SJ10 model, we have got this set of gravity disc from 64 internal dia, okay, 64 mm internal dia, 65 mm internal dia. So as we can see, the gravity disc will be looking somewhat like this. So this is the internal dia we are talking about, 64 mm, 65 mm, 66 mm, up to 79 mm can be the maximum diameter of the inside diameter of the gravity disc for this model. Similarly, for different model, if we talk about the most common model, which is SJ50, here SJ50, it starts from 86.5 and goes up to 115 mm. So these are the number of gravity discs which have been supplied by the maker, comes along with the purifier on board. Depending on our fuel oil viscosity, we will decide that, and the flow rate we want to keep, and the feed temperature, we will decide which gravity disc is the best one to be used. So there is a specific process through which this gravity disc is decided. We will come to that, that is through a nomogram, and especially for the GSH series or G Haydn's principle series, there it is because a clarifier, it is like a clarifier, okay, it is working like a purifier clarifier. So there is no heavy liquid outlet, no heavy liquid outlet in this, due to which what happens, because of no heavy liquid outlet, the gravity disk diameters are set. So though there is no need to change gravity disk for separate viscosity of oil. That is one advantage of this G Haydn principle. Only one set of one gravity disk for a set size has been given by the maker, comes installed with the device, and does not need to change the gravity disk upon the change in viscosity, because there is no heavy liquid outlet. Okay, so no need to change the gravity disk. There is no risk of the interface shifting. Okay, in case your interface is shifting also, there is no chance of heavy liquid going into either side, because there is no heavy liquid outlet, only it is being blocked, closed. Okay, so for SJ for G Haydn's principle, we have this number of size of gravity disk for SJ 50, 60, 70 or 84 mm, depending on this big size treating capacity of the purifier. We have got the diameter of the gravity disk as decided by the maker. So only these three are the gravity disks for the G Haydn system. Now come to how we will decide on the gravity disk selection. So this process is called a nomogram. So specifically nomograms are there, which are plotted as per the as per the fuel oil type, to decide on the type of gravity disk. For the G Haydn system, we do not need to change the gravity disk. It has been fixed by the maker himself, because there is no need to change the gravity disk in that system. We'll see how the gravity disk is decided by the nomogram. Okay, so let us, here one example is taken. So basically there are two fundamentals for deciding the gravity disk. Okay, let us take one example 1 and then we'll go to example 2, and from these two examples it will be clear as to how we decide on the gravity disk selection. Okay, so the specific gravity of the oil at 15 degrees centigrade is known. The specific gravity is 0.925 in one case at 15 degrees centigrade. The treating temperature, as we have seen the temperature viscosity diagram above, from there we can get the treating temperature. It was 70 degrees centigrade, found to be 70 degrees centigrade. Okay, feed rate we have decided that we will keep at 3000 liter per hour. So on the basis of these three parameters, the specific gravity at set at 15 degrees centigrade, the treating temperature that came from the viscosity temperature diagram, and the feed rate, we will find what should be the size of the gravity disk for optimum purification. Okay, so now this is the nomogram. So basically in the nomogram, what do we see? In the y-axis we have got the specific gravity, on the x-axis we have got the separation temperature, on the this block we have got the feed rate in the liters per hour. Okay, now let us see the example 1 type. Okay, and this is the set of the gravity disk provided by the maker for this set model. Okay, from 66 to 79. Okay, so only this much can be the set of gravity disks that we can use for this model. Now we in the example 1, the specific gravity was given as 0.925 at 15 degrees centigrade. So the initial value here is the 15 degrees centigrade. Okay, so at 15 degrees centigrade, 0.925 in example 1 is this 0.925. okay, and we are aware that we will keep this separation temperature at 70 degrees centigrade. So this is the line for 70. This point is the 70 degrees centigrade here. Okay, so this is the 70 degrees centigrade. Now what we have to do, we have to match the specific gravity line. So there are specific curves like this. This is a falling curve. So for 0.925 we have to ride on a falling curve and match it with a line drawn from these 70 degrees. So one line will be passing from the 70 degrees centigrade line in the temperature curve. From that we have to match this 0.925. So as we get a value here, intersection point, this intersection point has to be extended up to a value of 98 degrees centigrade here. Okay, here 98 degrees centigrade, this one is the 98 degrees centigrade. So we have extended this up to 98 degrees centigrade. From 98 degrees centigrade we have decided that we will keep the feed rate at 3000 liters per hour. From this point we have to intersect, we have to match these 2 points, 3000 liters and the point at 98 degrees centigrade, this point number 2. okay, so this point number 2, if we match, it is cutting at a value here 79. okay, so the internal diameter for the gravity disk in this case becomes 79. So this is the 79 number of gravity disk that we will, 79 diameter we will be using for this curve. The only point here is that we have taken the falling curve. There are rising curves also. Okay, we have taken the falling curve. Okay, the specific gravity of the oil is known at a certain temperature. Okay, so the only difference is here it is known at the 15 degrees centigrade. When the specific gravity of the oil is known at 15 degrees centigrade, you will use the method 1 where we will take the falling curve, otherwise if the treating temperature is known at some other temperature, say at 60 degrees centigrade, 70 degrees centigrade or 50 degrees centigrade, so specific gravity at 50 degrees centigrade at certain temperatures, because that is what manual says, at certain temperature is known. So here it is known at 50 degrees centigrade. So in this second case the specific gravity is 0.944 at 50 degrees centigrade, 0.944 at 50 degrees centigrade. Treating temperature is 98 degrees centigrade and the feed rate is 1250 liters per hour. That is what we have decided. Okay, now we can see in this diagram the example number 2. Let me take another pen for this explanation. Okay, for the example 2. In example 2 we see that we are 0.944 is somewhat this. We are following a upward rising curve. Instead of taking a downward curve like this or this, we are taking an upward curve and we are matching it at the 50 degrees centigrade line. So 50 degrees centigrade we have drawn a line perpendicular to the 50 degrees centigrade here and we are matching it with the upward rising curve. From the upward rising curve we are matching it here and then we are following. Now we came to the point where we are aware of the specific gravity at a certain temperature on the nomogram. Now we will take a falling curve again. Just a second. So we taken a falling curve here, falling curve like this. Now we match it at 98 degrees centigrade here. From the 98 degrees centigrade, since we have decided that we will keep the feed rate at 1250 liter per hour, this is the point where it is 1250 liter per hour, and we have to intersect both this point, we have to match. So it is cutting at 71.5 mm. So 71.5 is the internal diameter of the gravity disc. So that's how we see there are two methods, or there are two scenarios from which the gravity disc has to be decided. Either you are aware of the specific gravity at 15 degrees centigrade, that is because that is the beginning of the curve here at the 15 degrees centigrade. And since we are not aware at 15 degrees centigrade, the nomogram asks us to take an upward rising curve like this and match it with the 50 degrees centigrade, or say we are aware of the specific gravity at 60 degrees centigrade, so we will match it at here at 60 degrees centigrade. Okay, somewhat like this, match it at 60 degrees centigrade, and then we will join it again. Now at this point, now we will take a downward curve, okay, falling curve. So first the rising curve, then the falling curve. The best is that you are aware of the gravity, specific gravity at 15 degrees centigrade, so directly you can take a falling curve and match it with the separation temperature at whatever separation temperature we are willing to keep as per the previous explanation, and match it with 98 degrees centigrade and then cross it. So that is how the gravity disc is decided. All further explanations are for the model and type of gravity disc, that type of oil. So we have number of nomograms coming in the sections in the model, like SJ10 may with a heavy oil A, what can be the gravity disc. Okay, so similarly number of gravity discs example will come depending upon your manual on board, or whatever your say purifier is there on board. On that basis you can plot it on the curve and find the exact value of the size of the gravity disc. So basically the process is that same. Okay, then thank you, we'll meet for the next session.